We have learned that before ventricular contraction, a series of cells generate and conduct electrical excitation. Body fluids are conductive, so this electrical excitation can be transmitted to the body surface to form electrocardiogram. Electrocardiogram. The abbreviation is ECG, is an important auxiliary means of cardiac examination. How is it formed? What waves does it include? And with what significance? What is the clinical application? Let's learn electrocardiogram to settle all these questions. In 1842, French scientists Carlo Matteucci first discovered the electrical activity of the heart. In 1885, Dutch physiologist William Einthoven recorded ECG waveforms from the body surface for the first time, which created the history of surface ECG recording and won the Nobel Prize. Having been developed for more than 100 years, ECG is becoming more and more perfect. It has the advantage of clear record, small size, easy to carry, automatic analysis, and diagnosis. Next, we'll learn the principle of ECG. A series of cells have transmembrane potential changes before myocardial contraction. Action potential of IC node is conducted to both atria. At the same time, it is transmitted through the preferable route, AV junction, bundle heath, and branches to Purkinje fiber. At the end, cause the excitation and the contraction of the ventricular myocytes. These electrical changes can be transmitted to the body surface and form ECG. In recording ECG, the placement of the electrodes and the connective circuit are called leads. ECG leads include limb lead and chest lead. The waves recorded are different in different leads. Comprehensively helping doctors to diagnose disease, we mainly introduce ECG waves on the standard second limb lead, which from the right wrist to the left ankle. ECG includes 4 waves and 3 segments. The heart excitation starts from IC node and is transmitted to both atria, forming P wave. The normal duration is 0.08 to 0.11 seconds, and the amplitude is less than 0.25 millivolts. P wave reflects the process of atrial depolarization. If the atrium is enlarged, P wave is high and sharp. If the conduction between 2 atria is abnormal, there will be double peak in P wave. After P wave, there is a wave group with short term and high amplitude called QRS complex. The first downward wavelet is Q wave. The second upward big wave is R wave, and the third downward wavelet is S wave. QRS complex represents the process of ventricular rapid depolarization with a duration of 0.06 to 0.1 second. With the conduction blocking in left and right branches, ventricular enlargement or hypertrophy, QRS complex is widened or deformed. After QRS complex, there is a wave with long duration and a low amplitude, called T wave. T wave reflects ventricular repolarization. At normal, T wave should be in the same direction with QRS complex. In ischemia, T wave is low and flat, even inverted. In hyperkalemia or acute myocardial infarction, T wave is high. The interval from P wave to Q wave is called PR interval. 0.12 to 0.2 seconds represents the conducting time from atrial to ventricle. PR interval is prolonged, or QR complex disappear, or in AV blocking. QT interval is the interval from the beginning of QRS complex to the end of T wave. QT interval represents the time ventricular depolarization and repolarization. QT interval is inverse related to the heart rate. The faster the heart rate, the shorter the QT interval. ST segment is between the end of QRS complex and the beginning of T wave. It represents both ventricles are depolarized. There is no potential difference between cells. Therefore, ST segment is on the equipotential line. In myocardial ischemia or necrosis, ventricular potential difference still exists after depolarization, so ST segment will shift. Electrocardiogram is one of the most common examinations in clinic. It can be used to detect abnormal heart rhythm and conduction, myocardial ischemia and infarction, cardiac enlargement and hypertrophy, and judge the effect of drugs or electrolytes on the heart. However, it should be noted that ECG cannot directly reflect the contractile function of the heart. Today, we learned ECG. We should master the basic waves and the according significance. That's all for this class. Thank you for listening. See you.